the first group we're going to be looking at are alkanes. Alkanes are hydrocarbons that contain only carbon and hydrogen single bonds. And the general formula for alkanes is the CnH2n plus 2. So that kind of helps us. If we know how many carbons we have in the carbon chain, we can figure out how many hydrogen. So let's say I have 4 carbon. So carbon 4. So to figure out how many hydrogen I'm going to have, then I take 2 times 4 and then add 2. So that would be C4H10. So that's the general formula for figuring out alkanes. So I have some more examples here. So pentane is 5 carbon. So if I want to know how many hydrogen go with the 5 carbon, so I just take 2 times 5, that's 10, plus 2 gives me 12. So C5H12. And then heptane contains 7 carbon. So it'd be C7, and then H is 2 times 7, so 14 plus 2 gives me 16 hydrogen. So it's just an easy way to, if you know how many carbon go along with the name of the organic the alkane, then we can figure out how many hydrogens based on this formula. We're going to be representing the alkanes or any of our organic structures using these different formulas. So first of all is the structural formula. So in intro chemistry, we learned how to draw Lewis dot structures. So that would be a structural formula. So it just shows how the atoms are connected. It doesn't give us the geometry of the molecule, but it does show how all the atoms are connected together. Whoops, sorry about that. If you have repeating units like the CH2, so we have, CH3 on the ends and then CH2 in the middle, we're gonna be able to shorten that in our next formula. So again, we're just showing all these single bonds connecting the carbons to each other and the hydrogens. In the condensed structure, it's just a shorthand way of drawing the structure of the molecule. So you can see I have the structural formula there, and then I took it and condensed it. Instead of drawing the single bonds, we just kind of assume the single bonds, So we know that we have, so here at the end, it does look like this, right? But instead of showing the single bonds, we show it just CH3. So the hydrogens are all connected to the carbon, but we need to remember that the carbons are connected to each other here with a single bond. So if I have repeating units like the CH2s there in the middle, so I've got 3 CH2s here, I can just put them in parentheses and then put a subscript showing how many of those I have. So it's a nice way to, again, condense the structure. So we have the structural formula, we have the condensed formula. Whoops. And then we have the line structure. So for the line structure, we don't use the symbols. So we don't actually write, C and H. We show the carbon atoms and their hydrogen are represented by a zigzag arrangement of lines. So it's just kind of understood that the carbon, where they are, and the hydrogens along with them. Okay, so I've drawn here, I wouldn't put CH3, right? It's just understood that at this point, that's CH3. At this point, it's CH2, 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 and CH3. So just by showing that zigzag line, we know what is represented there. So going from a condensed formula to a line structure, so both of these are exactly the same, but just different formulas are being used. So you can see we have We have 8 carbon in our line here. So 1, 2, or in our chain 3, 4, 5, 6, 7, or I'm sorry, 9, 8, 9. So there's 9 there. So that's represented right here, the 9 carbon. And then this right here is CH3, and that's right there is CH3. So those are represented here. Okay, so we can, again, just to show you how we can go from condensed to a line structure. And then on the next slide, we have all 3 formulas again, and we have the aromatic ring, or the ring of carbon. Okay, so we have the structural formula. You can also do the condensed formula for the ring, but here for the condensed formula, we do show the bonds between the carbons, not the hydrogens, but the carbons, and then the line structure. Again, we assume we have a carbon, 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 and we have enough hydrogen to get it to 4 bonds. Okay, I want to go back because I meant to mention, so if we have anything branched out, we will show, the branches. So what I'm talking about is these right here. These are branched out. So we do show the bond right here and right here. So we may have some bonds on a condensed formula if we have branches, but if it's just a straight line of carbon, then we won't show those bonds. Okay, so we're going to do an example. Draw the structural formula, condensed formula, and the line structure for octane. Okay, octane has 8 carbon, so we're going to start with the structural formula. Okay, we're going to do blue. So I'm going to write 8 carbons. 5, 6, 7, 8. Okay, then we're going to put the hydrogens in. I'm just going to draw the lines first. So again, we're going to put enough hydrogens around the carbons to give them 4 bonds. So the one on the end here will have 3 hydrogen. All the ones in the middle will have 2 hydrogens. Okay, so this is the structural formula for octane. Sorry, it's not super great trying to draw on the iPad. There we go. So that would be the structural formula. Then the condensed formula, a little bit easier. We're going to have CH3 on the end. And then I have 6, right? 1, 2, 3, 4, 5, 6 carbons in the middle. Then I can put CH2, 6, and then my last CH3 on the end. So there's my condensed formula. And then the line structure is the easiest. Okay, so we need 8 carbons. So 1 at the end there, 2, 3, 4, 5, 6, 7, and 8, right? Just count 1, 2, 3, 4, 5, 6, 7, 8. So we got all of them. Okay? So those are the examples of all 3 formulas you can use in drawing organic structures. And just to show how to go from a line structure here to a condensed formula, you can go in between both. Okay, so these two are exactly the same. So we have, this right here is just this right here, okay? And then this right here is this right here. And then these two are right here. Okay, so we can go in between the different formulas or structures. So it's important to know the names of these different structures because, especially in your lab book, I think usually asks for a condensed formula. So you need to be sure you're drawing the correct formula. You don't want to draw a line structure when it's asking for a condensed formula. So just be careful with that.